Yes, you can power a house with a magnifying glass, but not the way you're probably imagining it. You're not holding a hand lens over a wire hoping electricity magically appears. You're using a large parabolic mirror or Fresnel lens to concentrate sunlight into intense heat and then using that heat to drive an engine that generates electricity. I'm going to explain exactly how this works, why it's not some crazy internet theory, and what it actually takes to set up a system that can generate meaningful power for your home. Let's start with the basic physics, because once you understand this, the whole concept makes perfect sense. When you used a magnifying glass as a kid to burn leaves or fry ants on the sidewalk, you were concentrating sunlight from a large area into a tiny spot. That concentrated energy created intense heat in that one spot. The same principle works at larger scales. A parabolic mirror or Fresnel lens that's 3 feet across can concentrate sunlight from that entire 3-foot circle into a spot the size of a quarter. That spot can reach temperatures over 2000 degrees Fahrenheit. Now, what do you do with heat that intense? You use it to power a heat engine, specifically a Stirling engine. A Stirling engine is a type of heat engine that runs on temperature difference. One side of the engine is hot, the other side is kept cool, and that temperature difference causes a piston to move back and forth. That moving piston turns a crankshaft, which spins a generator, which produces electricity. It's the same basic principle as a car engine, except instead of burning gasoline inside cylinders, you're applying external heat to one side of a sealed cylinder filled with air or helium. So the complete system looks like this. A large mirror or lens focuses sunlight onto the hot side of a Stirling engine. The engine converts that heat into mechanical motion. A generator converts that motion into electricity. That electricity powers your home or charges batteries for later use. This isn't theoretical. This technology has existed for decades. The Philips company built experimental Stirling engines powered by concentrated sunlight back in the 1950s. The technology works. It's just not widely commercialized for residential use. Now let's talk about what it actually takes to set this up and how much power you can realistically generate. The size of your mirror or lens determines how much sunlight you can collect. A 3-foot diameter parabolic dish collects about 7 square feet of sunlight. On a clear day, that's roughly 700 watts of solar energy hitting that dish. Not all of that becomes electricity. Heat engines have efficiency limits. A well-designed Stirling engine might convert 20 to 30% of that heat into mechanical power. So from a 3-foot dish, you might get 150 to 200 watts of electrical output. That's not enough to power an entire house, but it's enough to run several LED lights, charge phones and laptops, run a fan, or power a small refrigerator. It's useful power. If you want more power, you scale up. A 6-foot dish collects 4 times the area, giving you 600 to 800 watts. 2 of those systems give you over a kilowatt. 3 or 4 give you enough to handle most daytime household loads. And here's something important. Unlike solar panels that only work when the sun is shining, a Stirling engine doesn't care where the heat comes from. You use concentrated sunlight when it's available. When the sun goes down or clouds roll in, you can switch to a propane burner or a natural gas flame as your heat source. The engine keeps running. You keep generating power. You're not dependent on batteries or the grid. Now let's address the obvious questions people have about this. First, is it safe? Yes, if you're careful. The focused spot of sunlight is extremely hot, but it's small and predictable. You don't point the mirror at anything you don't want to burn. The engine itself runs warm but not dangerously hot. It's no more dangerous than operating a gas grill. Second, is it practical? That depends on what you mean by practical. It's not as convenient as flipping a switch and getting instant grid power. You need to position the mirror to track the sun, either manually or with a simple tracking system. You need to maintain the engine. You need to switch fuel sources when the sun isn't available. But if practical means cost-effective and functional, then yes. You can build or buy these systems for a fraction of what solar panels cost, and they work in conditions where solar panels struggle. Third, how much does it cost? A DIY parabolic dish can be built for $50 to $200 depending on materials. A small Stirling engine can be built for $200 to $300 or purchased for $500 to $1,000. Add a generator head for another $100 to $300. You're looking at $500 to $1,500 total for a complete system that generates a few hundred watts continuously. scale up from there based on your power needs. Compare that to solar panels. A similar power output from solar would cost $2,000 to $4,000 for the panels alone, plus inverters, charge controllers, batteries, and installation. The magnifier engine approach is significantly cheaper for the same result. Now here's the key insight most people miss. You don't need to power your entire house with one system. You can start small, generate a few hundred watts, and use that to offset specific loads. Run your refrigerator during the day from your magnifier engine instead of from the grid. That alone might save you $20 to $30 a month. Build a second system and run your home office equipment. Build a third and handle your lighting. Each system you add chips away at your electric bill. And because each system is independent, you can build them one at a time as your budget allows. You're not committed to a massive upfront investment. Here's what this looks like in practice. You set up your first system in the backyard. On sunny days, it generates power from concentrated sunlight. You run an extension cord to your refrigerator or to a power strip in your office. That equipment now runs on your generated power instead of grid power. When evening comes, you either switch the engine to gas heat if you want to keep running it, or you just shut it down, and those loads go back to grid power overnight. Either way, you've reduced your grid consumption during peak daytime hours when electricity is most expensive. Over time, you add more systems. You offset more loads. Your electric bill drops from $200 to $150, then to $100, then to $60. Each system you build pays for itself in saved electricity costs within a year or two. This is how you realistically power a house with magnifying glass technology. Not with one giant system that does everything, but with multiple smaller systems that each handle specific loads. And yes, it actually works. People are doing this right now. They're just not talking about it in terms of magnifying glasses. They're calling them solar thermal generators, or concentrated solar power systems, or Stirling engine setups. But the principle is the same. Use a lens or mirror to concentrate sunlight. Use that concentrated heat to drive an engine. Use that engine to generate electricity. It's simple physics. It's proven technology. And it's available to anyone willing to learn how it works and put in the effort to build or buy the equipment. I've put together information in the description about how concentrated solar systems actually work, what components you need, and realistic power output expectations for different sizes. If you want to understand alternative approaches to home power that go beyond standard solar panels, subscribe for practical explanations of what's possible and what it actually takes to implement. Can you power a house with a magnifying glass? Yes, just not the way most people imagine.